Time is an illusion. Lunchtime? Deliciously so. And it's also a very perplexing puzzle. Mostly because we believe things about time that are just not true. And when you try to mix fantasy with reality, you create paradoxes. Like the paradox we get when we try to imagine going back in time in order to change the past. The problem is, you can't. I know this will upset many people, but the events happen in only one direction and cannot be undone, not for reasons of entropy or topology, but for the sake of causality. Why causality? Well, for one, the speed of causality is actually experimentally linked to time. As you may know, it was Albert Einstein who showed us that when we measure the speed of light, regardless of the speed we're moving through space, you will always measure the speed of light to be moving at the same speed. That speed is the speed of causality. It was this insight that gave Albert the ability to slow and even stop time, like a true Time Lord. But even he didn't have any way of traveling backwards in time, and this is because of causality. Causality dictates the direction of action through the mechanisms of cause and effect. That gives events their logical order and prevents tampering of causally linked events, since changing the events of the past will eliminate the causal factors that motivated you to travel to the past in the first place. However, this may be irrelevant because it's unlikely there's anywhere to go. In fact, the concept of a timeline where the past, present, and future exist all together is likely just an illusion, since we have no credible evidence to support the idea of traveling through the timeline in the way we think of it in movies, where you could go back in time and talk to your past self. Instead, we only have evidence to support the idea that there is only here and now, only one you, and you are limited to slowing your own personal rate of animation relative to others, and that's it. This means that time dilation is more akin to suspended animation rather than actually traveling through a timeline, which eliminates the grandfather's paradox and other paradoxes like it. To me, this suggests that we are three-dimensional beings living in a four-dimensional universe where time is an illusion created by our memory of our own personal set of events, animated by our motion through the fourth dimension, which is governed by our total spatial movement at a constant speed known as the speed of causality. Now I know that four-dimensional space will be difficult for many to comprehend. However, this way of thinking solves many of our current problems with our understanding of the universe. So let me tell you why we need the universe to be made of four physical dimensions instead of the way Einstein described it, as it three physical dimensions in one dimension of time. Firstly, the math of general relativity demands four dimensions of space. When Albert figured this out, he assumed the fourth dimension to be the dimension of time. And in a very real way, he was right, but not in the way he thought. Because the fourth dimension is also a physical dimension, just like the three other physical dimensions, except for our orientation to this dimension, which associates our movement through the dimension with time. Secondly, four-dimensional space requires the point particles behave the way they do in quantum mechanics, which we will cover in the next video. And thirdly, special relativity needs four dimensions of space in order to cause the laws of physics to behave the same in all non-accelerated frames of reference. This is because the laws of physics are not as stable as you might think. They behave differently at different speeds. Yet, they seem to be the same in all non-accelerated frames of reference, regardless of our motion relative to each other. This happens because we are in a four-dimensional universe. To understand this, you have to understand that how four-dimensional space really works. In a four-dimensional space, you can't stop, you can't even slow down. In fact, the speed your matter came into existence at is very, very, very likely the speed you will leave existence at. In a four-dimensional universe, when you stop in the X, Y, or Z dimension, what you're really doing is moving all of your motion into the fourth dimension, which is the T for temporal dimension. As well, the opposite is true. When you start moving in any of the X, Y, or Z dimensions, what you're really doing is taking your motion from the temporal dimension and putting some of that motion into one of those physical dimensions. This is the true cause of time dilation, because your motion through space is a constant known as the speed of causality, otherwise known as the speed of light. Four-dimensional space is the reason why we measure the speed of light to be a constant regardless of our motion relative to each other, because the photon is stationary relative to space. Now I know what you're thinking. You're thinking, I thought light was moving at the speed of light. Well, yes and no. The photon is emitted into the temporal dimension at the speed of causality, or otherwise known as the speed of light, but we are also moving at the speed of causality in what is essentially the opposite direction. Thus, the photon will be stationary for the exact same reason that a soccer ball shot out of the back of a pickup truck at 40 miles an hour, while the pickup truck is moving at 40 miles an hour in the opposite direction down the road, causes the soccer ball to be stationary relative to the road. If you were to measure the speed of the soccer ball from the perspective of the truck, you would measure the speed of the soccer ball to be moving at 40 miles per hour. Not because the ball is moving, but because you are moving. In the case of the photon, it's stationary relative to the temporal dimension, and because it is a point particle, it is also stationary relative to space. This is the reason we measure the light speed to be the same in all non-accelerated frames of reference. Since our motion in a four-dimensional universe is a constant, and the photon is stationary relative to space. Just as the ball is stationary relative to the road, it is what our speedometer is measuring our speed relative to that matters. Now that you can imagine a photon being ejected into the temporal dimension and being stationary relative to the temporal dimension, we now have to apply a spherical distortion to our perspective of the temporal dimension. This is caused by our motion relative to the temporal dimension, and it is described by special relativity. To visualize the distortion of the temporal dimension, you can imagine a reference point for three-dimensional space where the three perpendicular lines cross each other and represent the x, y, and z dimension. In order to visualize the fourth dimension from our perspective, you would have to apply the distortion caused by our motion relative to the fourth dimension, and thus its perpendicular line would be spherically distorted. This means that the next point in the temporal dimension is a spherical shell inside or outside of each spherical point, and thus the direction of the temporal dimensions are in and out, which means we're in motion through the temporal dimension at the speed of causality inwards. Why inwards? Well, if the photon was emitted into the temporal dimension and it's stationary relative to it, and it moves away from us outwards, then we must be moving the opposite direction inwards. Due to this distortion, you could think of the temporal dimension as an omnidirectional dimension, and the three other physical dimensions can be considered another omnidirectional dimension. Then you would graph your speed through these two omnidirectional dimensions. Our true speed will always be the hypotenuse of these two speeds, and the speed is the speed of causality, because speed is a ratio of motion through the x, y, and z dimension by your motion through the t dimension for the temporal dimension, or how you experience time. This has been an overview of how motion through space creates the illusion of time from my book, Temporal Quantum Relativity. If you want to find out more about how four-dimensional space and how it gives birth to everything from nothing, you might want to check it out. You can find the links in the description. But don't worry, I wrote Temporal Quantum Relativity for everyone. So I left out the equations and instead added many drawings in order to help get these difficult ideas across to more people. And of course, please subscribe to get my next video in this series where we will bust Einstein's spooky little problem.